Hello. Um, Today I'm going to be solving the circuit for this value IO right here. Um, we're assuming this op amp is ideal, and um, well, actually, yeah. So I guess if it's ideal, we'll also assume it's rail to rail. So the max output voltage would be 12 volts, positive and negative. Um, so first thing we're going to notice is that we have a virtual ground right here, right? So 0 volts. And this is 0 volts too. We have well, I said virtual ground, but I meant um, this is grounded and op amps have a virtual short across the input terminals. And this current source is pulling 1 milliamp through here, right? And since the op amp is ideal, we also know that the input current is 0, which tells us, oh, sorry, if my hand's blocking, that we have 1 milliamp coming through here. So let me get my calculator. Oh, so yeah, might help us to find the voltage across this resistor. So um, 9 kilo ohms over 1 milliamp is 9 volts. All right. So we have 9 volts right here. Which I think does make sense because it's within these 12-volt rails or these 12-volt power supplies for the op amp. It can't put out more energy. It can't put out a higher voltage than it's supplied, of course. Um, and we have 1 milliamp leaving this node right here. Okay, so then I suppose, yeah, I thought this would be easy, but I don't have an idea of how much current we're expecting to come out of here. Because I can calculate the currents going into this node right here. But it doesn't, well, okay, so, yeah, okay, sorry, I just got confused for a little bit. Um, so what I'm thinking is that we're going to have a current coming in here and a current coming in here, but the sum of these currents going into this node is going to be greater than 1 milliamp. So we know from Kirchhoff's current law that I naught is going to just be the leftover. So let's just calculate these currents real quick because we know that the voltage across both resistors is 9 volts since these terminals are connected to ground. So 15k ohms times, or sorry, because let's remember Ohm's law, V is equal to I times R, and we're solving for current right now, so, right. Let's pull up my calculator real quick. So we have 9 volts over 15, and let's use decimals. So we have, what would that be? Well, I'm getting 0.6, so zero point 0.6 milliamps. And then we're going to find so that's 0.6 milliamps coming through here, right? And then 9 volts over 6k ohms. 9 over 6 is 1.5 milliamps. Okay. So in total, we got 2.1 milliamps, and that's entering the node. And then we have 1 milliamp plus I naught leaving the node. So um, Kirchhoff's current law actually states that the sum of all currents um, the sum of all currents entering a node is equal to 0. But what I like to do is I just like to write the currents entering the node on one side and the currents leaving the node on the other side. Um, and all that's left to do right here is to solve for I naught. So we'll have 2.1 milliamps minus 1 milliamp is equal to I naught. And that leaves us with 1.1 milliamps is equal to I naught. And we've solved the problem. How exciting. And when I'm done, I like to circle it, do a big circle with a purple pen or something like that.